It's snowing. Why? It's April. Hi everyone and welcome back to this very fine April morning in Ithaca, New York. My name is Grace and I recently completed everything for my PhD in aerospace engineering at Cornell University. My dissertation was on trajectory design and mission planning for cislunar space operations, and now I'm using all the skills that I gained to study the physics of gymnastics. Right now I'm just waiting for the carpool ride to pick me up so we can all go to practice. There's only 2 practices left of the semester, so I'm trying to film as much as I can so I still have stuff to talk about after I lose gymnastics gym access. Alright, so after watching everything back that I filmed this morning, I decided I didn't like any of the footage for today's topics, so instead we're going to look at last week's video. There's some good stuff I have today, just not for what I want right now. It also turns out I didn't save the tracker workspace properly last time, so now I have to set up everything again. Hello, post-processing Grace from the future. Please enjoy this sped up B-roll clip of me reselecting all the data points, and also with another very bad hair moment. Maybe this is something I'll get right in the next video. I filmed this earlier in the day when it was still the afternoon. It's now the evening when I get around to discussing the rest of this section. I've also watched the weather cycle through sun, clouds, rain, snow, clouds, and sun in less than an hour, so if you think the lighting lacks continuity, that's because it does. Anyways, some general housekeeping notes. I'm thinking about doing a video that goes into more detail about how I'm using Tracker. There are some future projects that I have in mind that will require additional Python code for simulation and analysis. When I get to that point, I'll include a link to the Git repo and talk about the design process in a video too. For now, I want to get through the dynamics fundamentals. The way I'm envisioning this first set of videos is talking through mechanics concepts like you would in physics class, building up to more complex topics in orbital mechanics. And because there's only one more practice left in the semester, I'll be using old footage to cover the fundamentals. That is, unless I can find a playground. Then I might be able to get new footage for some things. I also might have to start showing pictures of food and do day-in-the-life content to put together a more substantial video. I can also find out what the Venn diagram intersection is of engineering, gymnastics, and lifestyle vlogging. Luckily, this is a side project for my portfolio and not a day job. Okay, analysis time for real. Last video I talked about position and velocity. Today we're going to add to that and get into acceleration. Acceleration is the rate of change in velocity over time. The most well-known acceleration is probably acceleration due to gravity. It's about 9.81 meters per second squared, or 32.174 feet per second squared at sea level. Sometimes engineers will measure whatever it is they're studying in terms of 1 gravity, or 1g. For example, if anyone was keeping up with the Artemis 2 launch that happened a while back, you might have heard the live stream broadcasters talk about the G's the astronauts were experiencing upon launch and splashdown. This was about 4 G's. To put this in perspective, humans can withstand about 2 to 5 G's for about 10 to 15 seconds without training. With specialized training, like what fighter jet pilots and astronauts go to, they can increase that. So with all that in mind, we can go back to looking at the round-off back hamstring back tuck clip. I have acceleration data for my wrists currently displayed over here. The three plots I'm showing are acceleration in the x direction, which is left-right, acceleration in the y direction, which is up-down, and the total acceleration that combines the x and y components. And what we see in the plots is that for the most part, my wrists hang out around 100 meters per second or less. That's where the bulk of all the data here is showing. They briefly spike to about 375 meters per second squared going into the back handspring. And there's another spike that's around 260-ish meters per second squared coming out of the back handspring, about to go into the back tuck. For convenience, let's round 9.81 meters per second squared, the gravitational acceleration due to gravity, and we'll round that up to 10 to make it easier for ourselves. So that's about 37.5 and 26 Gs respectively, way higher than the 2 to 5 Gs for an untrained human like myself. So how is this still safe? These are my wrists. Blood is definitely rushing in and out of my hands at abnormal speeds, but there's no critical organ that's moving the way that my wrists are. Now, I have not been tracking my head placement, and maybe I should be, but for now, we can use my elbows as a proxy, because in theory, my elbows should be covering my ears the entire time. Now, that's not actually true, because my form is bad, but one, I'll fix that eventually, and two, it's good enough. So here's the elbow data. My elbows hover around 50 meters per second squared or less for the most part, with a few spikes up to 100 coming out of the back handspring at takeoff for the back tuck and during landing. We can ignore that last one though, since my arms are not near my ears and are instead preparing to stick the landing. There's also a much larger spike during the back handspring that reaches around 210 meters per second squared, and yet I'm still alive. The amount of time that I spend above 50 meters per second squared for this large peak is a fraction of a second. You can see that right here at around 2.069 seconds, and then I drop back under at 2.436 seconds. Humans are robust enough to withstand high Gs for extremely short periods of time. So I'm spending a fraction of a second experiencing over 5 Gs during this first half of the back handspring. So this was a fun video to make. I hadn't looked closely at the acceleration data last time and wasn't really sure what to expect. I had to look up human-safe levels of Gs, so that was pretty fun to learn. Hopefully you all learned something too. Anyways, thanks all for clicking and watching. I really appreciate it. Hopefully you found this fun, entertaining, and educational.